everyone, welcome back to our channel Learn with Sanjivani. So first of all, thank you for your valuable support and sorry for the delay. I was busy with my work. So let's coming to the point. In previous video, we saw about floor plan in theory as well as terminal execution. So in today's video, we are going to see about the next stage of PD, that is power plan. Yes, power plan. First of all, I want to tell you about the introduction of power plan. So first, what is power plan? Yes, power planning means the name itself, it has power. Yes, we need to deliver the power to the entire design is nothing but power planning. Yes, that is the simple definition of power planning. So now I want to tell you the definition of this power plan. We have two definitions of power plan. First definition is, yes, in power planning, power grid network is created to distribute power to each part of the design equally. First definition of the power plan. Second definition is, it is used to provide power to macros. Yes, in our design we have macros and standard cells, right? So macros and standard cells within IR drop limit. Yes. Before going to the definition, what is meant by IR drop? Yes, I want to tell you the first what is the definition of IR drop. Yes, IR drop is nothing but it is a voltage drop or voltage loss in the power lines due to resistance. That is nothing but IR drop. I will text here, voltage loss in power lines. Power lines due to flow of resistance. Yes, this is nothing but IR drop. It is used to provide power to macros and standard cells within the IR drop limit. Yes, within the IR drop limit, we have to provide the complete power to macros, each and every macro and each and every standard cell. That is the main agenda of this power planning. Without power, there is nothing execution in the design or chip. So we need to provide power, then only chip will works, right? We know the formula V equal to IR, right? So if power, see, let's simple example. If power supply is equals to 1 volts, then due to this resistance value, cell may get only 0.9 voltage. Where is the 0.1 voltage? That is the loss of IR drop. So that's why IR drop will consider in the power planning as well. Okay. So now we got the intro of the power planning. Now before going to the deep, I want to discuss 5 new terms in power planning. Okay. So now 5 terms of the power planning. The first one is rings. Yes, what is meant by rings? It is carries VDD and VSS around the chip. Yes, we know the power and ground, right? That is nothing but VDD and VSS. So these rings are carries the VDD and VSS around the chip. See, I want every macro and every standard cells to provide power, right? So by using these rings only, we need to provide VDD and VSS to each and every single macros and standard cells. So for example, it is like a power line around the motherboard edges. So we all know about the motherboard, right? So by using that motherboard, we have power lines around the motherboard. So along with that, power will distribute around entire chip boundary. That is nothing but the rings. These rings will distribute the power entire chip or entire boundary. Okay, that is nothing but rings. This is the duty of rings. So now second one, stripes. Okay, the second thing is stripes. So what is meant by stripes? It carries VDD and VSS from rings. Yes, from rings across the chip. Stripes is nothing but it carries VDD and VSS from the rings. Rings only it will get the power. So see, simple example, it is like a internal PCB tracks. Inside chip, power will comes from the edges. Yes, that is nothing but the stripes. So now, the third one is rails. Yes, what's mean by rails? I will show you the image also. Then only you should understand properly. So now, yes, it connects VDD and VSS to the standard cell. Yes, standard cell. Yes, rails will connect the VDD and VSS to the standard cell VDD and VSS. See, every cell has VDD and VSS. Every cell, every macro, anything will have internal power that will comes from VDD and VSS. Yes, that VDD and VSS will connect to these rails. Okay, that is nothing but rails. Now, fourth term is tracks. Yes, we all know about the tracks. Simply see, tracks is nothing but the connection between pads and rings. Yes, pads and rings. Before going to this, I will tell you that pads also. So now, fifth one is pads. Interference power IC to the outside world. Yes, it is coming from the outside of the chip. That is nothing but the pad. So tracks is nothing but it is connection between the pads and the rings. Okay, just these are the definitions. I will show you the image, then only you will get the clarity of these terms. Okay, so what's meant by tracks? Tracks is nothing but it is like a main charge cable. Okay, it carries the power from the socket to the phone. So that is nothing but the tracks. Now coming to the pads. Pad is nothing but it is like a wall socket. Power comes from the outside into the chip. That is nothing but the pads. Wait, I will show you the image now. So yes, now see the image. This is the power planning. Whenever we give the power planning to all the cells in the chip, it should be showing like this. Yes, see this is the connection of, see internally this is the connection of power planning. Okay, core boundary and the die boundary, this is all we know. So now what I want to tell you is, see, in the core and die boundary also it has VDD and VSS. Okay, same VDD and VSS. For every cell, for every macro, we need to provide VDD and VSS in the top and bottom. Okay, that is the main agenda. See, these are the power pads. Sorry, this is the power pads. Okay, these are the power rings, power straps. So complete design, if we provide power to the design, it will be looking like this. Okay, so now let's coming to the 5 terms of the power planning. Yes, this is the 5 terms of the power planning. Okay, see, first one is rings. Yes, these are the rings which is having VDD and VSS. Okay, this is the rings. Now pads is nothing but out of the chip. See, this rectangular box is nothing but our chip. But while coming to these pads are coming from the outside of the chip. That is nothing but the pads. See, these are the vertical layers. I will tell you the layers also. See, first one is horizontal layer and the vertical layers. Vertical layers means it should be like this. Okay, horizontal means it should be like this. Okay, like this it will be seen. Okay, this is nothing but the vertical layers. Now coming to the rails. See, inside these we have rails. Red color is nothing but the rails, and the straps are nothing but this connection between VDD and VSS is nothing but the straps. Okay, nothing but the connection between the rings and the pads. Yes, these are the pads and these are the rings, but the in between these connection is nothing but the trunks. These are the, this is nothing but the trunks. The connection here it shows clearly this connection is nothing but trunks. Okay, we should know about these five terms, then only we will stand in the terminal execution. Okay, now I will tell you only just advantages and disadvantages. Okay, first one is it has a stable power distribute to all cells and macros. Okay, so that advantage is it has stable power distribution to all the cells and macros. Provide proper VDD and VSS to each and every cell in the design, then only chip will works properly. If not, chip will fail, right? So now the second thing is reduces IR drop. Okay, we should minimize the voltage loss for better timing. In the coming stages we need to do the timing also. Yes, so time for the sake of timing we need to reduce the IR drop. That's why we already mentioned here only limit. Yes, this is the IR drop limit. We need to specify the IR drop limit. Okay, for the sake of coming timing stages of timing. Okay, so now third thing is immunity means it avoids overheating. Okay, it avoids overheating or damages or hotspots. All these will be improved. Okay, so these are the advantages. Now coming to the disadvantage is thing is consumes area. Yes, consumes area. Those rings and stabs takes chip space. Okay, yes, we have limited space of chip, but inside that need to provide everything whatever needs for chip. Now it consumes more area and it has complex design. Okay, in this complex design it needs careful power planning and the analysis also. So by all these consideration we need to provide proper power connection to the chip, then only it will work. If not, chip will fail. That is the main point. Okay, sorry, today agenda is very simple. Provide proper power to all the cells and macros in the entire chip. Okay, if we not provide the power, what will happen? Chip will not work, right? Yes, chip will not work and chip not send our data whatever we require. Whatever we send the data, that will not come out of the chip. What is our requirement? We need to send one data that will come from the out of the chip. That is our requirement. For that purpose we need to provide proper power plan. So if not, chip will fail. So that is today's agenda, power planning. So hope you understand well. If you have any doubts, please comment in the comment section, and in the coming videos I will show you the real power plan in the terminal. Thank you for watching this video. Please do like, share and subscribe our channel. Thank you.